Question 6. Aquarium 1 contains 4.6 gallons of water. Louise will begin filling Aquarium 1 at a rate of 1.2 gallons per minute. Aquarium 2 contains 54.6 gallons of water. Isaac will begin draining Aquarium 2 at a rate of 0.8 gallons per minute. After how many minutes will both aquariums contain the same amount of water? So, what I would like you to first do, so we're going to have a pause point right here, and for reflection 1, and it is going to be over here. So, which answer did you choose? Does the rationale off to the side, so the rationale right here, that's this stuff over here. So does the rationale from the answer you chose match what you did? All right, it's going to go back. And so from here, what we're going to do is, there are multiple ways that you could solve this, but I think the easiest way is to write two equations and then set them equal to each other, since we're looking for this thing where they're the same. So we have two equations. So the first one is going to look like this. So Aquarium 1 is going to has 4.6 gallons in it. That's just a flat rate or flat amount. And it's being filled, so that's going to be an addition plus 1.2 gallons per minute. So it's not just 1.2 gallons, but it's 1.2 gallons per minute. So I'm going to use I guess I can use an M for minutes. Okay. And then since we're looking for when they're the same, we are going to set them equal to each other. And then we're looking at Aquarium 2 being having a total of 54.6 gallons just starting out, so there's no variable, and he's draining the aquarium at a rate of 0.8 gallons, so minus 0.8 gallons per minute. So I'm going to use an M there as well. Okay, so what I'm going to do is go ahead and solve this. So now we have our equal sign in the middle. So what I would like to do is draw a line. It's going to get a little messy maybe. I'll try and keep it clean. So the first step is to see if there's, since we don't have like terms on both sides, so if I were to circle my constants and box my variables, circle my constants, box my variables. So there aren't any like terms, so we're going to go ahead and move our least coefficient, which is this 0.8. So I'm going to add 0.8 m to both sides. Plus 0.8 m. So over here that becomes 0, and then we're left with 1.2 plus 0.8, which is 2m. And then we have to carry down what's left. So 4.6 plus 2m equals 54.6. And then from there, since we have constants on both sides, we're going to move the constant that's on the same side as the variable. So we're going to subtract 4.6 from both sides, so that goes 0. And I'm going to subtract 4.6 here. When I subtract 4.6, we get just 50. Okay. And then that equals 2m. Okay, I'm going to rewrite that down here. 2m equals 50. And then my last step is to divide by my coefficient, which is 2. 2 divided by 2 is 1, so we're left with m. And 50 divided by 2 is 25. And that is answer choice C. So, before we finish, pause point for reflection 2. In the rationale for option B, how did the student land at this incorrect answer? All right, so hopefully you read over the rationale behind option B for pause point 2, or pause point for reflection 2, and that will be it.